So let's now call Marco Vicentini here for the next presentation from Lilly. He is a data scientist. He graduated from the Sapienza University in Rome. He works as a data scientist and he deals with the digital solutions of Lilly's website. He develops algorithms, solution, and data analytics for the improvement and monitoring of processes. So before switching to the use case, I would like to tell you something about Lilly. For those who don't know us, we are a pharmaceutical company. The headquarters are located in Indianapolis. We have more than 38,000 employees worldwide, and 9,000 of which are engaged in research and development. We carry out our clinical trials in many countries, pretty much everywhere between South America, China, France, Spain. And we sell products in more than 120 countries. Now, what we do in Italy other than production is the whole commercial and manufacturing part. So in Italy, we have approximately 1,300 employees, and we've been investing a lot in the last few years. Now, this is what we do usually. We deal with drugs for oncology, diabetes, and pain in general. In Italy, we are focusing on manufacturing. And in this slide, you should notice our investments in research. So let's switch to our use case right now that we picked for Seeq. Now, our goal as a team is supporting drug production. So we want to increase drug production. That's our goal. That's why we work a lot with process engineers, and we also have different areas of opportunities to do that. So we work on analysis, alarms, anomalies, and we try to reduce them. So what we are going to talk about today are automatic cycles anomalies. So let me explain better what our goal is. So basically our business motivations. During production, we have some downtime because we need, between lots of production, to carry out activities such as preparation of components, preparation of material, decontamination cycles for next cycles. Now, if decontamination has issues, you need to repeat the cycle a number of times depending on the contamination. So this represents downtime, extra downtime, compared to what we calculated. Our goal is to give engineers the possibility to be faster in this detection. So what do? I cannot name these variables, unfortunately. So just imagine a cycle which is divided into phases, such as heating, decontamination of units, and here you have sensors, which are different for each cycle. Now, what we know, thanks to engineers, is that cycles are repeated. For each process, cycles are repeated. So in this case, we have this phase for each cycle. The blue line represents the repetition of the cycle. If the cycle changes shape, it implies a problem. For example, heat, temperature. If temperature starts from 10 instead of 40, it's a problem. it means that something is changing in the product itself. This leads to the failure of the cycle. And that's where we need to solve the issue. And how do we do that? We have the actual curve, which is the sensor of that cycle in that phase. This is what we can replicate. And the reference curve, which is the golden curve, the ideal curve, what we want to reach, for example, a certain temperature in a certain phase. So what we do with Seeq is we detect time series distances. So we have a Euclidean distance or a permutation distribution distance to see if curves are similar in their behavior, and we do that for different cycles. So we have the blue curve and the yellow curve, and every cycle. And the curve changes, of course. Now, what happens is that we want to detect the Euclidean distance going over a certain threshold, a statistic threshold, telling us there's an anomaly. So that means do something before the cycle fails. That's the process, many distances, cycles, and a red warning when the threshold is being overcome. So here are some overviews of our data architecture. We use both the Python language to replicate processes, but also Seeq functions in the workbench. First of all, we define the capsule conditions to indicate interests, so the baseline, the cycle, etc. We define the reference cycle, and then we do the metrics. And that's what Seeq does through a formula used in the data lab. The visual part is the second part of this process. So we want to give engineers the possibility, or users, the possibility to just click on Seeq and have everything ready. So the interest phase, the number of cycles, the golden cycle, the actual cycle, and the distances. Everything ready in one click. And one last thing that we do is Seeq gives us the possibility to directly switch to a page of a workbench that we want to see, so that engineers don't need to do anything. They do everything inside the platform. We do that with Data Lab because thanks to Python we can replicate this with one click on all of our processes. So imagine 10 phases. Each phase has 30 probes, for example, and with one click everything goes together. At this point, we push everything into Workbench through Python, and everything's ready and set. So this is the situation you can see here, of course. And the useful thing is you can add signals. An engineer can add distances, can update signals if something's going on, and they can save everything. So we also connect this Seeq part to the Power BI, so that we create a control power that I'm going to show you in just a second, summing up all these metrics, all the cycles, all the phases, all the processes, everything all together. So basically we have red parts if something's off, yellow if something needs to be verified, and green if everything's okay. Now, going back to Seeq, we can basically return to anything we're interested in. Now, I'm sorry I needed to cover some things, some confidential data, but this is the situation where for this cycle, for this phase, everything's okay, everything's regular. This means 92% of the probes that we are checking are okay. Now, something can go wrong, and you can identify which probes are not okay. And you can check that for each cycle, and see which cycles are having issues. So I'll go check that specific probe. Perfect. I'm going back to that previous slide about distances. These are the distances, Euclidean distances, golden cycle, and the cycles that you see in the columns. So you have those two red lines, which are the limit control, and all the other criteria. So the cycle started being out of control from here, more or less. Red, green, red, green, red, yellow, and then out of control. So from that button at the top, thanks to the data lab, you can go everywhere you want. You can go back to the phase you're interested in. You can go into the probe, you can verify it. And thanks to the filters on Seeq, you can check what's good and what's bad. And at that point, you can make decisions. Let's see what's happening. Let's change that probe. That's okay because the experience tells us that a certain thing is okay. So we basically decide something based on those data. Now, what are the next steps? First of all, we replicate solutions on processes, and that's very easy. It's always the same formulas. We already started doing that. We are at our 5th process that we are monitoring right now. And then we have the retraining phase. Basically, we give engineers information saying, on that day we had a perfect cycle, or statistically, we know which cycle is having some issues or is just average. And you can do that automatically. The third point is a multivariate correlation analysis that we carry out for alarms, for warnings, for performance, for example. And the fourth point is new for us, because we just acquired a new version of Seeq, so now we're able to have an automatic warning implementation through MS Tasks, so on Microsoft. Now, I haven't done it personally yet, but yesterday we tried it. So basically, we have a lot of data on Seeq, and the whole segmentation part for data processing is completely carried out by Seeq, on Seeq, real time, very quickly. It's very useful because engineers can automatically look at time series, so they can view data basically real time. And once they've seen the distances, they can make decisions, they can insert other data, and they can note what's important, they can save it. So that makes everything easily scalable, and with Power BI integration, we're able to have a process control tower and a notification system that's very quick. So I'm done with my presentation. Thank you. Thank you, Marco. If there are any questions, you can raise your hands. How do you do the Power BI integration? Well, with Seeq functions in Data Lab, you can use the information, or you can use the OData, which are a Seeq function, an automatic Seeq function, to read automatically from Seeq to Power BI. So it's a tool that's in the system. So Power BI reads automatically Seeq? Yes. So it creates a link, and you have all the Seeq data. You can set the Power BI the way you wish. We don't do that right now because we're also using other data. Sometimes we also include data that are not on Seeq, for example, machine alarms. So that's more useful for us, but it's a personal preference. It depends on what you need to do. Thank you. Any other questions? Yes, over there. Now, you mentioned the automatic retraining. Yes, sometimes probes change, and that's fair. They need to change because we make changes on machines. So that means that the golden cycle, so the new cycles, will be different automatically. And everything that's red will be marked as red will become green, because if the reference cycle changes, then also the other criteria will change, of course. As well as those limits that I showed you before, these here, these are statistics. So I can tell Python, include the data between January and May and mark them as good, because I know that everything went well there. And you build these limits with the yellow and red lines, and if everything changes, our goal is not to give Seeq new information, but seeing automatically that everything changed. So you can do that very quickly. So the update is automatic? So the retraining is carried out on cycles that are considered good. Well, if you need to see that a cycle is changing, you will have to check if every cycle from today to December will have new criteria, new temperatures, new values. Values will have changed, so that will automatically become the golden cycle, the reference cycle. Ideally, that's our next step. Our goal is that this golden cycle is automatically updated. Thank you. There's also another question. Thank you, Marco. I know that Francesco was very interested in building a series of different tools that integrate the peculiarities of everything. So in general, I wanted to understand how you perceived Seeq compared to other tools that you have, because you do have many different tools. So compared to existing infrastructure, what did you think? What turned out very well with Seeq is that Seeq is a very easy tool to use. So unlike Power BI, which is a static element, engineers sometimes are not able to look at the time series, whereas Seeq allows them to see everything very easily. Seeq is updated real time, and it's very fast. It has a huge power in that, so it allows you to calculate different distances automatically, things that we were not able to do before. So for all these data every day, for all processes, we couldn't do that, not so quickly. We couldn't show a time series to our users. Now, today we're able to do that. There's one more question. I didn't get an answer to my question. Just kidding. Did you validate this solution, BNG? In the GNP validation process, everything takes time. So if engineers need to use this solution officially, the GMP process will need to be taken care of. I don't deal with that, but sometimes Power BI solutions had to be validated. Not all of them, but some of them. It depends on the use. Any other questions? Very quick question from me. I was noticing that you have two limits for distance, one at the top and one at the bottom. So is there an alarm when things go too well? No, basically we inserted a mark above which we wanted to check whether the time distance was above or below the golden threshold. But I didn't tell you this not to confuse you, but basically it just tells us whether it's above or below the threshold. That's it. Thank you. I think I was just wondering. No, of course, that makes sense. Thank you, Marco.